Hi everyone. So I am Indranil Ghosh from the School of Fundamental Sciences, Mesa University. So today I'm going to talk about football or soccer data analysis, pedagogic introduction. This is my Twitter handle, and this is the link to my website. Thanks PyCon AU for giving me this opportunity to speak at this conference. So I'm really glad that I'm present here with you all. So this is my second year speaking at this renowned conference, and welcome everyone. So I'm going to talk about how to get open access event data from StatsBomb using the package called StatsBombPy in Python. Then how to draw a soccer pitch using MPL soccer package. How to visualize a pass network for a particular team in a particular match, and how to use network-X module to analyze the pass network to draw pass maps along their corresponding heat maps of players from a particular team in a particular match. And finally, we'll talk about how to implement computational geometric concepts like convex hulls, Voronoi diagrams, and Delaunay triangulations using a Python package called scipy.spatial. Like any other package, we use pip to install StatsBombPy, and then the open data from StatsBomb can be accessed, and please go through the terms and conditions section stated at their GitHub documentation page. We will go step by step to understand how to extract the relevant data and using the StatsBombPy package. So we also need to import the package. And next we get access to the competitions dataset. What the competitions dataset looks comp dataset looks like. So we have a competition ID and a season ID. So both these together act as a unique ID for extracting a particular row. We also have the country name. Here actually it's the continent on from where the league belongs. So here it's Europe. The competition name is Champions League. And the gender is male. So unfortunately, the first 15 rows here that I'm showing is of gender male. But if you print the whole dataset, you will see there are rows where genders are females too. Season name is 2018-19 or 17-18 and so on. We can extract the column names of comp. And this is what the column names are, competition ID, season ID, and so on. Now let us make sense of a particular row from the comp dataset. So for example, if we look into the row where the competition ID is 16 and the season ID is 1, we notice that the country name is Europe, the competition name is Champions League, and the season name is 2017-18, and so on. So suppose we are satisfied with the above information and we want to analyze a game from 17-18's Champions League season. So we use both this competition ID and season IDs. And this is what we write to extract that particular row. So mat equals to sb.matches, competition ID equals to 16, and season ID equals to 1. So this gives us the particular match from where we will extract the event data. So this is the mat dataset, and we see it also has a match ID, which is again the unique ID for this particular dataset, mat. But here we have only one row for this dataset. And the match date when the match took place, the kickoff time, as we know, it's an European Champions League game. So it was on 2017-18. The home team was Real Madrid and the away team was Liverpool. And the home team score was 3 and the away team score was 1. Now we use this match ID to extract the events and store it in events dataset. Okay. So the events dataset fetching us the events data for the particular match, and that's what it looks like. It has a large number of rows and columns. So we see that we are able to get access to all the events from the Real Madrid versus Liverpool match, and we can also print the column names using events.columns. Now we will see how we can draw a football pitch using MPL soccer, and this package was developed by maintained by Anmal Durgapal and Andrew Rollinson. Please go and check them out. And like any other package, we pip install it first, and then we also need to import the matplotlib and the pitch classes. So this is what we do here: import matplotlib.pyplot as plt, and from mplsoccer.pitch import pitch, where here p is capital. See that with the function pitch with again p capital, we set the pitch color to be grass, the line color to be white, stripe to be true, and so on. Okay, and these are different parameters that you can enter, and if you draw it, you will end up with this page. So this is the default one, the statsbomb type page, which is provided by the statsbomb package, where the x-axis ranges from 0 to 120 and the y-axis ranges from 80 to 0. And but there are different types of features that you can draw with the statsbomb package, except the default one, like apart from the default one. You can also set the color to be black, and this is what you will end up with. Then the default one, statsbomb there are different other features like opta, trackcab, skill corner, y scout, metrica sports, uefa, custom, and so on. Okay, this can be set using pitch type argument inside the pitch function. Here I have set the pitch type to be uefa, and here we see that x ranges from 0 to slightly above 100 and y ranges from 0 to 70. These are the most basic concepts covering the topic of drawing and visualizing a football pitch using MPL soccer. And now we will use the concepts from complex network analysis to draw a pass network for a particular team from a particular match, and then we will analyze that network using networkx package. So for that, we need to pip install networkx. We import networkx as nx. We also pip install seaborn and import it as sns. If you go back and look into the events dataset, you will notice that there is a column named tactics that provides us with the team lineups, formations, player IDs, and their jersey number from both the teams. Okay, so the corresponding row values for a column type gives us an idea about whether it was the starting 11 formation or was a tactical shift. So let us generate a completely new dataset only focusing on the tactics and the type columns, and we'll filter the data in such a way that the tactics column has no rows set to none. Okay, so that's what we do here. So this is what it looks like. Here we see the entry of the tactics column is a dictionary, but the key formation gives the formation of the players. The key lineup gives the player IDs, names, and jersey numbers for both the teams. Let's focus only on the tactics for the starting 11 setup from both the teams. And this is given. So this I got this idea from from the MPL soccer package documentation website, and also from the YouTube video by Mackay Jones, and you should go and check both these resources out. Okay, so we will build and analyze the pass network generated from among the starting 11 players from either of the teams. Okay, if we look into the first two rows of the type column in tact, we see that they are set as starting 11, one for each team. So let us separately fetch the data for the teams. So that's what we do here. So it's, as I said, it was the tactics column is made up of a Python dictionary object. And for now, we are only interested in the key lineup. Okay, so we just extract the information from the lineup key. If we then convert that into a data frame using from dict function of the pandas data frame, we end up with this. Okay, so we say that for the column player, suppose the ID is 5597 and his name was Kellen Navas, and his position is a goalkeeper, and his ID is 1, and the jersey number is also given. So we are basically interested in the players' names and their corresponding jersey numbers. So we will use a simple for loop and store the information in separate dictionaries for both the teams. Okay, so that's what we do here. Okay, so now we have collected the names and the jersey numbers of the players, the starting 11 players, from both the teams. From the events dataset, we will extract out the relevant columns for our pass network analysis. And these are the relevant columns: minute, second, team, type, location, pass and location, pass outcome, and player. So this is the first 10 rows of the events PN data frame. So minute, second, team, type, location, pass and location, pass outcome, player. Next step is to filter out the dataset by teams and store them as new datasets. Okay, one for Liverpool and one for Real Madrid. That's what we do here. As we are only interested in the pass network generation, we'll filter the datasets by keeping only those rows where type is set to be pass, and we'll discard all the other types. Again, view the first 10 rows of the filtered datasets. So we see that for Real Madrid, here the team is only Real Madrid, and it was the type is only pass. Location, here if you notice, the location is a it's a list of two numbers which gives the x and y coordinates, and same for pass and location. Okay, so later we will like separate this location column into location x and location y for the one column for x coordinates and the other column for y coordinates, and same for pass and location. Let us now very carefully observe the dataset. So suppose from events PN real dataset, we are focusing on the second and the third row. Luka Modric makes the pass at around 0th minute and 10th second, second row, and Danny Carvajal receives the pass at around 0th minute and 11th second. So in both the datasets, we now need to add two extra columns named as pass maker and pass receiver. But the pass maker column would be similar to player column, and the pass receiver column would be the player column, whose index would be shifted by one place in the negative direction. What I learned from the like MPL Soccer's documentation and the YouTube video by Mecca Jones. So go check them out. So this can be achieved by the shift function provided by pandas. So we will perform the operation on both the both events P and real and events P and live. Okay, so that's what we do here. So this is the modified dataset. So we see that we have added the pass maker column and the pass receiver column. Now there might be passes which were not successful. Okay, so one thing to notice is that in StatsBomb data, passes whose pass outcome are set as nan are actually the successful passes. Okay, so this is very important thing to keep in mind. We'll again filter the datasets by successful passes. So these are the modified datasets again. So it seems we have been able to logically clean and modify the datasets. Now we are only focused on building the pass network among the players who were in the starting 11. Okay. So for that we need the time when the first substitution took place. There were 3 substitutions for Real Madrid, and the first substitution took place at 36th minute at 17th second. Okay, and same for Liverpool. There were 2 substitutions, and the first substitution took place at 29th minute and 39th second. So that's what we do here with this sample code. We like try to find out the minute and second. So we use the minute value to like discard all those rows which appeared after that minute. Okay, all those events that occurred after that time. Now from the datasets we split the location and the pass and location into 2 columns, as I said, one for x coordinates and another for y coordinates. So inspired by the way given here, if you click in this link, you will see in the MPL Soccer documentation page, we will take the average locations of the starting 11 players on the field for a unified construction of the pass network. So for that we will use the aggregate function, and what it does is that we'll count the number of passes created by this player. Okay, so here avLocReal gives the average location of the player of a particular player from a particular team in that match. As I said, using the aggregate function gives the mean of the x and y coordinates for a particular player, and for Casemiro we see that the mean is 60.845 in the x coordinate and 31.836 in the y coordinate, and he completed 11 passes. Once we sort out the starting 11 players average locations in a game, we'll try to figure out the number of times a particular pass maker pass the ball to a particular pass receiver. Be cautious to keep the direction of pass in mind. That is, a pass from player A to player B is not identical to the pass from player B to player A. So it would give a directed network. So we'll use group by and the count function to count the number of rows where a unique player A passed the ball to another unique player B. So here we use the group by function, and here we just reset the index accordingly. And we see that here the pass maker is Casemiro and the pass receiver is Carvajal, and Casemiro passed only once in the entire game to Danny Carvajal. He passed 6 times to Toni Kroos. So we see that 6 plus 7, 8, 9, 10, 11. So yeah, there were 11 passes if you remember for Casemiro. That will merge the datasets avLocReal and passReal, and let us identify the left and right data frames for performing the merge. Okay, here avLocReal is the left data frame and the passReal is the right. So we just merge them, and this is what the new dataset looks like. So pass maker, pass receiver, the number of passes given by the pass maker to pass receiver, pass maker's average x location, x coordinate, pass maker's average y coordinate, and the total number of passes completed by the pass maker. So we see that it's 11 for all the cases, rows where the pass maker is Casemiro. And same for Liverpool. So finally, we will again perform a merge on these updated data sets for adding the average locations of the past receivers and the number of times the receiver received the ball. Okay, so that's what we do. And like we added this column, number of passes received by that particular player. So Casemiro, I think, received 24 passes. Then lastly, we will replace the players' names with their jersey numbers. Okay, and then we just visualize the pass network for both the teams. So we use the pitch function to draw the pitch, and then we use arrows to draw the edges from between the nodes, and the pitch dot scatter. So pitch dot arrows function does that, and pitch dot scatter function draws the nodes. The thicker the edge, the number of passes were played. So that's what it actually means. And yeah, so this is the pass network for Real Madrid against Liverpool, and this is for Liverpool. Okay. And now, as we have drawn the visualized the pass networks, we can perform some complex network analysis by analyzing our networks using some metrics. And let us first develop the isomorphic graph to the ones that we just saw, and by using the network X package. And the thing is, we don't need the average locations here. Okay, we are only interested on the nodes and the information about the nodes and the edges, but not about the locations. So what we do is that we create this dataset pass real new from pass real new, where the pass maker, we only take the columns pass maker, pass receiver, and number of passes. We use the nx.digraph function because it's a directed graph, so digraph function from network X, and then we add the edge along with the weight. Yes, so this is what it looks like. Okay, now we will use network X to find out the node degrees from pass network of Real Madrid. So by using the nx.degree function on greal, and we see that these are the node degrees. So node degrees means the number of passes the player was actually involved in. So for Real Madrid, we see that jersey number 8 was involved in the maximum number of passes. We can create the in degrees and out degrees too. So that means the number of in degrees means the number of passes a player received, and out degrees means the number of passes the player gave to some other players. We can also generate the adjacency matrix, and like we see the diagonal had all zeros. That means there were no self loops, so a player cannot pass to himself. Now we can work on a metric that focuses on geodesic distance between two players nodes, two player nodes in a graph. One way to implement this is to divide 1 by the weight column, and that will give a new graph. This is the graph that we end up with, and we'll perform the same operations to create a modified graph for Liverpool too. And now using this modified graphs, we can calculate the all pair shortest paths between the nodes players for both the teams. Let us compute first for Real Madrid. If you intend to find the shortest path between two players, like what would have been the shortest path for a pass from one player to another. So suppose we want to calculate the shortest path from the goalkeeper Keylor Navas to the forward Cristiano Ronaldo. We'll just type the following. So print this real 1 to 7, and we see that from Keylor Navas to Sergio Ramos, and from Sergio Ramos to whoever the player was with jersey number 12 to Cristiano Ronaldo. I think okay, it was Marcelo, and with him ultimately passing to Cristiano Ronaldo would have been the shortest path. And this seems like a good post-match analysis tool. I got this idea from discussing with Sarath Babu, and he's from IIST India. Now we can calculate the eccentricity, which is based on the shortest distance. So eccentricity of a player node P tells us how far the furthest player node from a P is positioned in the pass network. So this is for all the players for Real Madrid, and this is the average eccentricity. And for Liverpool also, we calculate the average eccentricity. We can also calculate the average clustering coefficient of a player. Real Madrid it's 0.182, and for Liverpool it's 0.276. So the average clustering coefficient lies in the range 0 and 1, where a value of 0 denotes the fact that none of the nodes are connected to each other, and value of 1 denotes the fact that the network is a clique, that is each node is connected to all the other nodes of the network. Also compute the centrality of each player, and for each node in either team's pass network, and understand which player was the most important. So more the centrality of a particular player, more important he was in that match. So for Real Madrid it was Casemiro, and for Liverpool it was Milner, right? So next we'll talk about pass map and the corresponding heat maps. So we'll again from the same match we'll again work on the fetching the pass data and visualize the pass map. And as we saw in, so this is the events data set, and so we'll like take the columns team, type, minute, location, pass and location, pass outcome, and player. Okay, so here we will focus on a particular player, and let's choose Toni Kroos because he is one of the best midfielders of this era. From events pass, we only take the player whose name is Toni Kroos, and this is what we end up with, the data set. Like the type column in events pass P1 has event types other than passes, but we'll only set to pass, and that's what we do here. And this is the data set where the type is only pass, and like this is what the pass map looks for Toni Kroos. So it's the pitch function, and like for successful passes we set the color green, and for the unsuccessful passes we set the color red. And for the heat map we use the Seaborn KD plot. Yeah, again I got this idea from Macajon's tutorial. And like if you want, you can also calculate the percentage of successful and unsuccessful passes for Toni Kroos, and we see that he had around 91% successful passes. So these are if you want, you can draw the frequency distribution. So now we'll focus on applying some computational geometric concepts on the event and tracking data. So for that we'll visualize the convex hulls from players event data. So we'll study how to develop a convex hull around these points, and from where a player had made a pass or had taken a shot in a particular game. So mathematically, if these points are contained in a set X, then the convex hull is the smallest convex set that contains X. So this figure has been adapted from this Wikipedia article. If you go and you will see, it has a lot of information about convex hulls. So we'll use the SciPy package. Go download it. So as we have been doing till now, let us pick the important columns from the events dataset, like team, location, type, and player. Here we only need the location of the players. So it seems like we only need our 4 columns for now, and we are focusing on pass and short events. Okay, so we set the type to be either pass or short. So that's what we do here. And then we'll next split the data into 2 data sets, one for Real Madrid and one for Liverpool. We will now extract the event data for Toni Kroos from events hull real. So we set the player to be Toni Kroos, and this can be applied to all the other players. And before computing and visualizing the convex hull, it is good practice to discard the outliers, okay, from the data sets. So we use the interquartile range, and we'll find the interquartile ranges for the columns location X, location I from the events hull Toni, and then compute the upper and lower bounds for the data. Any points lying beyond these bounds will be considered as outliers and will be discarded. Okay. So this is what we do here. This is the box plot for Toni Kroos's location conditions, and we see these are the whisker plots. And for location X, these are the outliers, and for location Y, we don't have those outliers. But yeah, this we can discard the outliers. And next, let us look into the events hull Toni dataset. And first, we'll collect all the points from the 2 columns as a 2D matrix. This comes in aid while drawing the convex hull. So points hull equals to events hull Toni location X, location Y. Dot values allows us to do that. Now let us use the convex hull function from scipy.spatial package, and we apply convex hull on this location X and location Y for events hull Toni, and then we just collect the useful information and visualize the convex hull. So this is the convex hull of Toni Kroos's field coverage. We can draw the convex hulls for other players too from either of the teams. And next, what we do is that we draw the we learn how to get the tracking data for a particular match, like for each for some particular instances of a match, and then draw the corresponding Dillon triangulations and Voronoi diagrams. So we'll try to understand how to get the tracking data from particular game using StatsBomb API. So again, it's given in their documentation. Please go and follow that if you want. So we need to import useful classes from the mplsoccer.statsbomb module. And as you remember, we use the match ID 18245, and from mplsoccer.statsbomb we import read event and event slug. The code is given here. This is the events and tracking. Look at the event and tracking datasets. So if we look closely into the tracking dataset, we understand that the column ID represents an unique ID for a short freeze frame. That is a particular instance of a match. Now we'll only extract the relevant columns: ID, player name, the locations X and Y, and the team. Now let us try collecting the jersey numbers. We'll use a different and easier approach from the one we have done here, the blog that I have written. So yeah, but we can follow this. To get the player information, use the following command by passing the match ID. So player info equals to sb.lineups, match ID equals to the one that we have been using. Here is the data set. We see that it has the jersey number, the country the player belongs to, player nickname, player name, and player ID. Now let us select a particular ID from tracking dataset representing an instance of a particular game. We will filter tracking by a ID value, which will give us the information of the locations of the players on the pitch at that moment. So these are all the unique IDs for a particular snap from a game. Let us filter the dataset now. So we use this short ID to be this. We just select a particular value from the ID column, and then tracking filter equals to tracking ID, where the ID is the short ID. And same for event. And the data filtered dataset looks like this. Okay. So we will now compute the Dillon triangulations from a team's player locations to get an idea about the possible links created among the teammates. So Dillon triangulations help us understand the links between teammates of a particular team. Go look into the Wikipedia article from where I took this diagram to understand more about Dillon triangulations. So we will import the Dillon class from scipy.spatial. We visualize the triangulations and the player positions at the instance on that page, and this is the code to do that. Go check it out. And yeah, so this is the Dillon triangulation for Real Madrid's. So I've linked to the Real Madrid's players, and the red nodes indicate the locations of Liverpool's players, and the white nodes indicate the Real Madrid's, and the black lines indicate the direct links between the players from a particular team at a particular moment, forming the Dillon triangulations. So the book Soccermatics, in his book Soccermatics by Dr. Sumter, he mentions that these lines have two useful indications. First, they portray the availability of a player, availability of passes among the players from a particular team, and second, they also indicate the no man's lines for players from the opposition team, meaning that if an opposition player is on one of these linking lines, then they are at the disadvantage. And we can also draw the Voronoi diagrams. Again, look into the Wikipedia article to learn more about Voronois. We use SciPy Special's Voronoi and Voronoi plot 2D classes to draw the Voronoi diagrams. And this is the Voronoi diagram. And the Voronoi diagrams give us the zones of each and every player on the pitch at a particular moment by breaking the pitch into distinct regions belonging to that players, indicating the field coverage of each player at that moment. So yes, this completes our section, and I think that's it from my presentation. So these are the references. Go check them out. At the end, thank you, wear masks, get vaccinated, and stay safe. Thanks.